how are we actually going to use the fact that we found all this thing? Okay, so there is a pattern in your formula book. It's actually, maybe you can get those bad boys out. I think you've got them.
I've been lost at this point.
Right. So in the formula sheet, you'll see it says 1.3 binomial theorem. Now, all this looks a little bit crazy wacky. All they've done is they've called the first term A instead of ours as an X, and the second thing they've called B. Okay, so that's the only difference there. This is what I want you to focus on. This part here. Okay? So NR, we've talked about that. Okay, that's the Pascal's triangles number. What did we say about the first term? Well, we said it started at the value of n, didn't we?
Yeah.
Yes? And then reduced by 1 each time.
Yeah.
And so our general number, oh, well, that was something else actually, sorry, I meant to get you to look at. Here, if that's the secret power of 1, that's the secret power of 1. What do we notice about these two numbers here?
They all add to n.
They always add up to give n. Yes? All right. So that's something else to notice. So that's where they get this here. So for our general term, it's going to be n take away whatever r was. Yes? And then b is to the power r. And actually, don't you can stop there. Okay? So this is our general term. So that's what we're looking at all the time. We don't need to learn it because it's in our formula booklets. Okay?
So we can scribble out this plus b.
Well, no, don't scribble it out, but this is the bit you're actually focusing on. This is how you're gonna use it. Now it's given you all of these terms to show you that there's lots of them, but this is the general one. Okay, so when we're talking about the general one, this is the one we're looking at. Okay? So all we have to do is to look at our expression and decide, okay, what's our A, and what's our B, and what's our N, and what's our R. So if we were to write the first 4 terms of this sequence, okay, x plus y, so let's just put x and y again, so that's nice and easy. So the first term would be 8, 0, following this, okay, x to the power 8, y to the power 0. Are we happy with that?
Yes.
Let me tell you the second term and maybe you'll be happier. So this would then be 8, 1. X to the power 7, y to the power 1. Yes? And then this would be 8, 2, x to the power 6, y to the power 2, 1, 2, 3, and then 8, 3, x to the power 5, y to the power 3. So then my first 4 terms. Well, obviously, I can't actually leave it like that. I actually need to know what these numbers are. What did we notice about all of the first numbers? They were always 1s, yes? You all notice that? So that's going to be a 1. And then obviously y to the power 0 is also 1. So this is just x to the power 8. Did we recognise anything about our first number in our Pascal's triangle? What is it always going to be? 1. So when it's 8, 1, what would our value be? It would actually be 8. So if we look at our Pascal's triangle, the first number that we're looking at is always the same as the value then. Okay? So this would be 8, x to the 7, y, because we don't know we might power 1. But now we do need to know the next number in Pascal's triangle. So, how are we going to do this? Do you want to write Pascal's triangle, or do you want to do the calc?
We write it.
Okay. We need some space. All right. So let's start. Are we 6 for 1?
Yeah.
Yes? So that would be 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. 1, 7, 21, 35, 35, 21, 7, 1. 8, 56, 70, 56, 58, 1. And obviously, once you go to the middle, as I can't remember who said it first, I think it was Gisela, said it goes, once you've got to the middle, you then go back down again. You shouldn't have different numbers on the second half, is what I'm saying. So what does that mean the value of 8.2 must be? I'm going too fast, sorry. Let's have some discussion. So you don't have to write this first line. It's just, that was just my way of connecting it to the general formula. Okay, so you could do that each time. You could skip straight to knowing that these terms start at 8 and go down by 1 and up by 1. But then what you must forget are these Pascal's triangles numbers, because that's the thing that sometimes people do forget to include those. So how you set it out is completely up to you, but yeah, that's my suggestion. Okay, so that would be the first four terms, but that was what we've been doing before. It was nice and easy. There was just an X and a Y. It starts to become more challenging when we've got stuff like this. Okay, the reason being is that we know that if we were to expand this, already we've got things like 4k squared, etc., etc., etc. It starts to become more complicated. So if we're talking to the power 5, it's a little bit trickier. However, it's not crazy. All you have to do is to acknowledge or recognise what would our A be. It's not a trick question. What's our first term? 2k, yeah? What's our second term? Be careful here. Huh? Minus 3. So far so good? And then we're going to do what we just did. We're going to use that general formula, but we've just got to be careful here, because when we are raising anything to a power, we've got to remember that the rules apply to both of the things. So here, if we've got, for example, a to the power 5, it would be 2k all to the power 5, which means that it's 2 to the power 5 and k to the power 5. Yes, does that make sense? So this would actually be 32k5. In a similar way, if we've got negative 3 squared, that's going to be positive 9. So you've just got to be really careful when, as soon as your terms are not just letters on their own, when numbers are being involved, you've got to make sure that when you're raising them to powers, that you're actually doing it correctly. Now, all of these words, it's not rubbish, it's all very important. But basically all of this says is that when we're doing this here, we just have letters and our Pascal's triangle number, which is great. But here, we're going to have our Pascal's triangle number as well as things like this 32 and this 9. So setting it out nice and neatly and carefully is really, really important. So if you're a bit of a scribbler, then it could be that you're going to make some careless mistakes here, so just be careful. So if we're writing the first 3 terms of this, okay, we know it's to the power 5, so our first would be 50, 2k all to the power 5, negative 3 to the power 0. Now, it could well be that the first term, you're going to look, Miss Harrison, why do you keep doing that? This is always 1, this is always 1, we don't need to write them. Completely appreciate that. So you might always want to ditch these two, because you know that that's always going to be the case. It's up to you. The second term would be 5, 1. Then it would be 2k to the power 4, negative 3 to the power 1. And the third term would be 5, 2, 2k to the power 3, negative 3 to the power 2.
Oh, and then we're going to finish this next lesson.